Hi all, welcome back. I am Vishwanath. In previous videos, we have seen how to install Microsoft SSMS SQL Server Management Studio, and also we have seen how to convert a business requirement to various models like conceptual model, logical model, and physical model. In this video, we will be using SSMS, which we have installed previously, and we will convert this into tables. We will create the database schemas, we and also we will create the tables, and we will play around with the SSMS in this video. Without any delay, let's get started. Our first step will be right clicking on it and saying as uh, create a new database. On the you need to select on the database, and then you need to say right click on it and then say as a new database. That will give you a new pop-up where we will be mentioning the database details. In this new pop-up, what I have got, I'll be mentioning as a university model, a university city, and I'll be before clicking on OK, I'll click on this script part. So you'll see like what is the data that is going to be injected by the server when we say like that. For now, I'll be clicking on OK so that the server will start invoking all the scripts in background. And if you look into this, it has various set of properties where it will be creating a database a name with this and setting the compatibility level, ASCII value, auto stats, updating. So there is various stuff that is happening when we create a database. So let's see how you can also receive a message saying that the database is now created successful. And let's navigate to a newly created database. If we expand the database session, now we have a new database called as university. Let's now go to the university, and we will create before we create a new tables, we will what we will do is we will start a query and we will create a schema. Schema In order to create a schema, what we have to use is the command create schema is a command. For example, if I want to create a schema, create schema, and I want to create a schema of demo. uh, I end my statement by using semicolon, and I can select the statements individually, and I can say as a F5 or just click on this execute button. Uh, Based on the results, we see the command is successful or failure on the console. Either we can use SQL editor, like how we can supply the commands, or we can make use of the inbuilt tools like a diagram. For example, if I want to create a new table, I can go to the diagram, and I can say that I am looking for a new table to be created. When I say like new table, I can click on new table over here, and I can where I'll be mentioning my table names from my initial diagram. My table name is going to be university. I'll just be typing university over there. University. University, and I can click on OK, where you can see a design of table will be populated, where we can also select the schema details over here, where we have created the schema as a demo. So I'm going to select that as a demo. So and the rest of the details as part of our diagram, which whatever we have created. If we look into our diagram, we have created a bunch of fields for university that we will be using, and we will be populating the tables as. So I will be using this diagram, and I'll be creating the rest of the tables by uh, taking a copy of this details, like each and every field. uh, Let me start with the first field, which is a university ID. I'll copy it, and I'll go to my SSMS studio, and I'll be pasting that over here. And uh, the data types, when it comes to the data types, SQL data types is an attribute that specifies the types of data of an object. Each column, like variable and expression, has related data types in SQL. You can use this data types while creating your tables. You can choose various data types. For example, if you are working on numeric data, you may choose a big int, which captures uh, a very huge value. And if you are working with either you can select as a big int or small int, a tiny int, byte, decimal, numeric, money, small money. These are the various types of numerical data. When it comes to the byte, it takes values from 0 to 1, and small int takes values from 0 to 225. Int tiny takes values from 0 to 225, and small int takes up to minus values from minus 32,768 to plus 32,767. And likewise, the other values, the ranges of other values are. And we also have in numeric data types, we also have like a float and a real, which will take the decimal points. And when it comes to the time or date type, we have date time combination, which will display the values in December 31st, 2022, for example. For in order to capture that information, you can use date time. You can also store the other information of time using a create timestamp, which we will be exploring in later part of our session. And the data model will not be binded to any one particular database. So if we are mentioning on the data model that it is going to be a numerical value, yeah, we can take a numeric of 18 comma 0 over here. And the other field on the for this one is a name, where we have mentioned name to be a test of 20. So we can mention that as a name over here. And what we can give as, instead of test as a 20, instead we can define it to be a varchar of 50, and I don't want it to be a null. And the third field in university is an address ID. For this address ID is a foreign key type. So again, I'm just selecting it as a numeric 18 of 0. What this values is basically, if you look into right hand side, you see like a precision is 18 and the scale is 0. When we are defining the numerical value, it is always better we use the values, uh, because it's a primary key. Definitely it will not have any scale, and hence I am not setting any scale value. And in order to set this as a primary key, all you need to right click, and you have to select as a primary key. We will also be you know creating the other tables in a similar pattern, where I'll be passing the video and I'll be creating rest of the tables now. So as part of the diagram, we have replicated the entire tables over here, and we will be doing small adjustments in teacher table. Instead of age, capturing the age, we will capture the date of birth, just like a student table, and we will select this as a date field. so that we can make use of the existing functions in order to calculate the age of a teacher. Or we can also have another field called as a HOD ID. All the teachers will be reporting to head of the department, and head of the department, typically he will not be reporting to anyone. So I will be allowing this ID to be null, and I am not allowing anything to be null apart from HOD ID. If you see the address column, I have also set like address 3 and address 4 that can take as a null. Um, and now we will be defining the relationships. In order to define the relationship, I think I have missed the value of spell. I think the A was missing. I'll be correcting that value. And in order to edit that value, all you can say as a alt enter, that's a shortcut, or you can right click and say as a, properties. Where once this window has opened, you can go there and you can change the value. Now, what we will be interested is to create the relationships on the tables. In order to create the relationship, we can select the table and say as a relationship. So over here we will be clicking on add button, and we will be defining what is a relationship on what table. We click on this window, and over here I'm trying to define a relationship on my teacher table itself, because all HODs should report to teacher itself. So how we have to define is primary key for this particular table teacher. Primary key is the teacher ID, and we are going to define a foreign key, which is nothing but our HOD ID, where we are defining as a primary key, sorry, foreign key. And we will also be defining one more key, which is an address table. So where we will be mentioning that whichever the key that we want to mention. For example, if we want to define the relationship between teacher and address, where we will be selecting the address table, and in address table the address ID is the primary key. Likewise, in teacher table, address ID is existing, so we are defining that relationship over there. If we can close it, now you see the self join on teacher, because HODs and teacher ID, and also there is a relationship between teacher and address. There is a relationship between address and university as well. So we will right click the university, and we will add the relationship, where we will be doing repeating the same exercise, where we will say like this is the the details in university is a primary key. So we will be mentioning like it is an address table that we are interested in for the university. So in the address ID we are selecting address ID, and the university again we are selecting the address ID. So in this way, the address ID of the university is having a foreign key relationship with the primary key of the other table. So also, I have noticed that in category was repeated twice, so I have deleted one of the category and have created the enrollment ID. Now that the design is complete, we have gone ahead and we have done few modifications, where we also wanted to know like date on which the student has enrolled. So I'll or I, I'll also be interested in capturing other details like status of enrollment, where I'll be mentioning as a small int, where it can typically take the values of saying whether the status is 1 stands for pending, or 2 stands for processing, 3 stands for rejected, and 4 stands for completed. Likewise, I can also have a field which is related to date type, where I can say as a status when it is um, complete, or probably I can say like enrollment date instead of status date. Uh, Enrollment date. So I can have that as a date, and definitely status is not going to be not null, and enrollment date, once this process is complete, then we are going to have that he's finally the application is successful. Once the application is successful, then we'll be having an enrollment date, and till then it can be a null value. So those are the modifications with our design. Now if we want to generate the tables, what we can do is we can select the table and we can generate it. So let's select all the tables and right click on it and say as a change generate script. That will give you a pop-up where inside the pop-up we can see that the details as we can select all the changes, and we will go through the script. Let me select all, and let me copy it into the notepad. Copy, cancel, and I'm using this query editor to discuss on the scripts, how it is going to be working as in terms of transactions. In order to control the transactions, saying that it is a one whole transaction, we will typically be saying like begin the transaction, and we have a set of commands where we are trying to say being an administrator, we are trying to say like a few operations to be on. So once these details are on, and then what we are trying to say is commit all these transactions, and again we are going to start a new set of transaction where we are trying to create a table address which is in a schema called demo, where we have defined our address ID as a numerical which is going to take 18. If you want to alter this properties for address, for example, you can go click on address ID, and also you can say as a properties alt enter on right hand side. You can see various properties. One of the properties that you see like is identity. If you set this identity to be yes, then the increment part will happen. So if we reselect again our tables, and if we say as a generate change, and copy that change again, you will see now for the address table, now you will see not null identity of one to one has generated. So let me copy the latest script once again. Copy, uh, and let me paste that. Likewise, I will be repeating for all the tables to increment it. So after doing those changes, I have pulled the script again, and you see for every table we are defining as a, we are altering the table by using alter command, and we are saying the constraint, and over here we are saying like a primary key constraint, and we are mentioning the details. You can also define the primary key word by here itself, where you need not mention this set details. It will be same as the above command, and we also have like a set of lock escalations which are to be committed on. So likewise, if we go to the another table, student, where we have like a student ID as a primary key, which I have just added directly to the table. And if you see like there is another constraint called as foreign key constraints. Typically, instead of if you want to merge it, you can still do it in this way. If you want to just merge it with the create table itself, you can say like my foreign key value, where I'm going to have it on this particular thing, and I can just close my bracket of my student of create, where So typically, merging them into a single create table will look like a foreign key, where we are saying like for on this probably for better formatting. Let me do how it looks like, where we are. I'm just trying to say like. This option. So making it in a single line, you see now the student table typically holds like student ID is a non-numeric value, and it has to increase starting from one, and it will increment. Next one will be one, two, three in that list, and it is going to be a primary key. And likewise, I have like a name variable binary which I have opted for, and DOB is a date field which is not null, and most of the fields in this table are not null. And currently for a foreign key, as I said, like it has a foreign key of address type. This is a foreign key where I'm trying to say like this has a reference to the above table which we have created as address ID. And over here, the operations, if you have seen it, on update, no action, on delete, no action. So we will talk about those operations, like the various other operations that we have is generally we go for cascade actions. If I'm trying to, like create these two tables from the script, I can just select those two queries and then run it. If the script is successful, yes, script is successful. Now that the script is successful, let's drop one of the tables. We will just try to drop the, address table alone. Uh, so now if we say like run, we get a exception saying like there is a reference to other table, so you cannot drop it. So when you have the the references, so in order to drop address, we always have to drop the child table first, where we will be saying like student, and we will be dropping that, and then we will be able to drop the address. And as we have discussed on these operations, like delete on update, I have just changed it to cascade. The relationship between like on delete, if you look into it as a no action, and the relationship between the cascade is that if the operation is said to be a cascade, what happens is when you drop the primary content of primary table, if there is any child records are existing, update will typically resist deleting part of it. When we say like delete on update, delete on delete, no action is set, and when we say as a on delete cascade, cascading effect is when a primary table is deleted, the records of the primary table is deleted, it will eventually delete the child table records. This kind of actions are required when you are processing data in a bulk, where you want to delete the data in a bulk, then you have to set this kind of operations. In generally, we tend to leave it as a default values, where it is going to take as on update no action, and on delete no action. So now let's go to our scripts, and I have also added drop statements which are very optional, and where now if we look at the create table scripts, what we have altered is we have clubbed as part of a create table scripts the primary keys, and as well as constraints like foreign keys, where we have also mentioned the reference and what should the table do on when it is updating a record, or when it is deleting a record. So we are good with it. So let's select all the scripts, and we can say as an execute. When we say execute, you see like all the commands are successful, and go to the tables and say as a refresh, and you should be able to see newly created tables on this part. I will also create a copy of this scripts on Git, and I'll share the link post completion of video, where I'll say like drop scripts and creating the tables, which will be a starting point if you have not followed anything in this video, but still you can use the scripts, and you can still create tables from here. So now that tables are created, let's start writing few insert scripts in one of the table for now. And in order to start using the insert statements, because we in most of the tables we have set the identity to be auto generated and incremented. If we have decided to also set the identity, then we have to say as a identity insert on that particular table to be on. So the statement will look like set identity insert. It should auto populate uh, identity insert. And let us take the example as demo category. This is the table on which we want to insert the data. So what we'll be saying is, on this particular demo category, identity insert to be on, and we have to now start writing our data. So in order to insert it, we have to use insert into command, insert into uh, and the table that we are interested to insert is on this table. And the values, when we talk about the values, we have to also talk about the details, so we will be specifying the order of columns in which we are interested to insert. Currently, I'm in as I have chose this particular table demo category, and I'm trying to copy both the column names. And now if you look into our statement, insert into is syntax, and this is the table name with bracket followed the number of columns that we are interested to insert into. And then again the syntax says that what is the values that we want to insert in that particular value. For example, if I want to insert one, and the category I want to say as a max, where I'm trying to say like this is my value. Likewise, I'll try to give another value. My bad. And under category name, it should be as a department. For example, like in engineering, we can mention as an electrical electronic engineer, or electronic communication engineering, or computer science, for example. Like if I want to, if I have planning to decide all the three records, if I run it, you will typically see like uh, the error has happened, because we have initially set this to be picked by whenever we are trying to insert it, we have mentioned earlier it to be auto generated, and so that system takes care of. If we want to manually make this query to run, then we have to say like set this identity to be on, and then we have to insert this records. So in order to retrieve the records, we have to use the select statement. uh, Select from this particular table, but we have to mention like what are the fields that we are interested in selecting it. For example, if you are interested only in picking one value, select this from the table, the particular table that we would be mentioning as. So if we have decided to select only one field in a particular table, then we can just say as a run. In the results, you see like these are the details that we have printed it. We will I will come up with a script that will create a lot of data, and I'll also share that script so that we can see the later things like how to retrieve, because in select we have various kinds of select, using a filter, using a sorting, using uh, using grouping, using having. So there are various clauses which we will be discussing much in detail. So for that, I think like the script has to be ready, which I'll be doing it offline, and I'll be sharing that script with you all soon. Thank you for watching this video. That's all for now. I'll meet you in the next video.